All right. Today we're going to be looking at exponential functions, their derivatives, their integrals, specifically with a specific base. We're going to start by doing this. I want to find the derivative of e to the 2x, but we don't know how to do it yet. So we're going to use the one method we can use, which is logarithmic differentiation. We're going to say y is equal to e to the 2x. We're going to do the natural log of both sides. So we have natural log of y equals 2x. We're going to take our derivative, 1 over y, dy over dx, equals 2. And then multiply both sides by y and plug back into y. So we get the derivative is 2e to the 2x. So based on this, you should be thinking, what do we have to do to get this derivative without logarithmic differentiation? Well, it looks to me like this is the derivative of the outside, because this is the derivative of the inside. Now, what does that mean? That means the derivative of e to the x is just going to be e to the x. And the derivative of e to the 2x would be e to the x times the derivative of the inside, which would be 2. And so on and so forth. And that is the idea behind e to the x. The rate of change of e to the x is equal to the value of e to the x. So the derivative of e to the u is e to the u times the derivative of u. The integral of e to the u is e to the u plus c. All right, so now we just have some practice for these derivatives. So like for this one, we have e to the 3x plus 2 times the derivative of the inside, which is 3. This one over here, we have e to the square root of x times the derivative of the square root of x, which is 1 over 2 root x. So derivative of the outside times the derivative of the inside. This one we're kind of combining logs and e's. So we have y equals natural log 1 plus e to the x minus natural log of 1 minus e to the x. And we'll take our derivative. So we have derivative of the outside, which is 1 over 1 plus e to the x, times the derivative of the inside, which is e to the x. Same thing over here, 1 over 1 minus e to the x, times the derivative of the inside, which is negative e to the x. If we get common denominator, we get e to the x minus e to the 2x plus e to the x plus e to the 2x over 1 minus e to the 2x, because multiplying the denominators we get a difference of squares. That leaves us with 2e to the x over 1 minus e to the 2x. All right? We could find the equation of tangent lines here and go through the process. Now this one, I would not recommend doing product rule each time. I would recommend pulling out the e to the x and doing one single product rule. And remember, when you're finding an equation of a tangent line, you do not need to find the full derivative simplified. You just need to find the derivative and plug in your x. We can also integrate. We'll use some u substitution here. So like for this first one, we'll say u is 2x, du is 2 dx. So 2 on the inside, 1/2 on the outside. Integral e to the u du. Integral of e to the u, as we said earlier, is just e to the u plus c. So we have e to the 2x over 2 plus c. Similar thing for the second one. You're just going to be dealing with a square root of x as your u. We can integrate ones that have e to the x in them but are not specifically using e to the x. So for example, for this first one here, you can say u is 1 minus e to the x. Du is negative e to the x dx. And so we have an e to the x dx. We need a negative e to the x dx. So we'll do negative integral square root of u du, which is negative u to the 3/2, 2 over 3. And then plug back in our u. So negative 2 over 3. And then 1 minus e to the x to the 3/2. Okay? Doesn't really change any of our real integration work. Similar thing for the second one. Just got to make sure you pull out the 2 first and deal with your signs. You're going to have some signage issue there. We can also use definite intervals here. So we'll say our u is negative x squared. Our du is going to be negative 2x dx. We need a negative 2 on the inside, so a negative 1/2 on the outside. New lower bound is 0. New upper bound is 1. Negative 1, sorry. Negative 1. 0 to negative 1. No, it's not erasing. There we go. 0 to negative 1, and then e to the u du. Integral of e to the u is, as we said before, e to the u from 0 to 1. Plug in the upper and lower bounds. This is the big thing people end up messing up with on these. E to the 0 is not 0. E to the 0 is 1, so plus 1/2 there, and there's our final answer. Okay. All right, if you have any questions, let me know. Y'all have a great day.